Hello everyone, and welcome. Um, get comfortable, and you can write in the comments "hi" so that I know that you can hear me. Meanwhile, I'm Veronica, the host for this event, and I'm an iOS developer for 5 years now. And as you may know, SwiftSofia is an open community for developers by developers, and as such, everyone is more than welcome to participate. We try to gather every once in a while and talk about different iOS and Swift topics. And if that's interesting to you, make sure to join our Facebook group and meetup group so that you don't miss any future events. Just to make sure, can someone write something in the comments so that I know that you can hear me? That will be nice. Thank you. But enough rambling. Um, Today's topic is mobile security testing, strategies, guidelines, and tools to test and verify our app is secure. And I'm happy to welcome today's speaker, Rachid El Khayari. Hi, welcome.
Hi, Veronica. Hi, everybody.
Hello. Rashid is a cybersecurity officer at Compass Group Germany. I was developer for more than 10 years as a side business. Um, can you tell us a little bit more about yourself and
Yeah,
about the topic?
yes, definitely. So, thank you for the warm welcome. My name is Rashid, and as Veronica already told you, I work as cybersecurity officer at Compass Group Germany for almost 2 years now. In March, it will be 2 years. Before that, I used to work as security researcher specialized on mobile security, and there specialized on iOS security for 11 years at one of the largest research companies in Europe, in Germany also. It is Fraunhofer. Since like the beginning of the iPhone, I was developing applications. Most of them didn't make them to the App Store. So for me, it was always like a side business or something that I did as a hobby. And I tried to figure out ideas on algorithms and stuff like that. And in my main job, I always used to work at security topics, especially iOS security. So I gathered quite an expertise there in the area of mobile security and iOS security. Today we'll be talking about mobile app testing and especially about cybersecurity testing. The idea is that most of applications are tested in terms of functionality, user interface, and you make sure that your apps don't crash and that they get approved by Apple. But the security topics are usually either not implemented at all or not tested. And that's like, I would estimate that it's like 90% of the application don't have proper tests for security functions. So we will talk a little bit about strategies and tools that you can use in order to test your applications. If you have any questions during my talk, you can just comment, and Veronica, will update me with the questions, and I'll try to answer anything if possible. So just to give you a little bit of background about me, this is a slide which summarizes me. So in the top left corner is a picture from me as a kid. I was born in 1982, so I'll be 40 this year. Below it, you can see a picture of my first computer. That's a Commodore 64, which got also released in 1982. So it's as old as I am. It's the first machine that I learned programming on. We used to program that in BASIC, which was a very, very, very old programming language, which has almost nothing to do with modern technologies like Swift. And on the right-hand side, you can see my newest project, as I've already told. I usually work on small apps that I think are interesting or funny or sometimes pretty useless. What you can see is a widget of my current app, which is not released yet, and it shows you how much time you still have to live till you die. That's the idea behind the application. So you can look out for it if it will appear in the App Store soon. Time to live. Yeah, that's, I think, me in a nutshell. My professional side is, as I already mentioned, I work at Compass Group in as security officer, and Compass Group is a company that is providing food and food services to other companies. So our main business is business canteens. So if you happen to work at a larger company, it's very likely that you're eating food on your break in one of our canteens. And we are a global company, so we are present in 45 countries all over the world. And we have like 55,000 numbers of client locations. So we serve around about 5.5 billion meals per year. And one of the countries that Compass is active in is Germany. In Germany, we have around about 15,500 employees. So it's a very large company even in Germany. Globally, we have over 500,000 employees. My main task in my business is to make sure that all the systems and all the applications, all the services that we are using within our company are secure and safe. And one part of it is mobile app testing, as you can imagine. Even in our area, we have a lot of apps coming in, so that you can think about mobile payment at point of sale, for example. And these are very critical apps where you have to make sure that everything is like secure. And yeah, and this is the context of my expertise actually, but I will start directly with the main topic. So the main topic today would be, why are we even talking about mobile security? So that's the question that I always hear when I talk about mobile security. It's like, why are we talking about mobile security? Isn't it just security in general? And aren't we just building an app on top of Apple's ecosystem? So iOS systems, iPhones, iPads are already very secure. Why do I, as developer, need to think about mobile security in the first place? And the question that I also hear quite a lot is, it's Apple's responsibility to make sure that the apps and the system is secure. It's not mine. I'm just a developer. So, and iOS is secure anyway. The applications are sandboxed, so you can't do much harm with an application anyway. And you can't break out of the sandbox anyway. So these are the main arguments that I hear when I talk about mobile security. And partially they are true. So Apple makes sure that their system is secure and they test the applications before you submit them to the App Store. But part of it is also wrong, because you have degrees of freedom as a developer. So if you build an application, you can do anything that the APIs allow you to do. And on top of that, you can even do stuff that is not allowed but possible. So there are, for example, private APIs that you can use, which are forbidden. But if Apple doesn't detect them in the app approval process, then you will get away with it. So there's a lot of harm that you can do with applications. It's more true for Android than for Apple. This is one fact. But even in iOS, you can do quite a lot with an application. And security is hard to get right. And there's a reason for that too. Mostly security is not really part of a standard developer career, at least not specific enough. So there might be the case that you learn this or that about security, but usually an app developer will not get a full-fledged course about standard best practices, security building blocks, cryptography. Topics are wide and broad, and usually this is not taught in a general engineering or developer role. So the question still remains, why do we need to care? And the answer is because it's a shared responsibility. It's shared between three main parties. It's shared between you, the customer, the user, to say, and Apple. So Apple trusts you with their devices, and the user trusts you with their data, and and sometimes even with their money. So if you think about, let's say, payment applications, the user trusts that your app is secure. So you can't get out of it just saying, okay, I don't care. I really just want to build an application. I don't care that much about how secure it is. So if you don't build a secure application, you will just misuse the trust that the user has put into you. And the second part is you can even do harm with an application. So you can cause the device to like behave in a way that is not proper. So you have to be aware of that responsibility, and you have to take into account that you share part of the responsibility as a developer, and that you can't get out of it just by saying, okay, I don't care. I want these systems to be secure. I'm just building an application. So the second part of it is most people will think about security vulnerabilities and attacks happening just to others, because what I hear quite a lot is, my code is proper. I did everything in the best manner. Maybe other people's code is not as good as mine, or maybe they are not as good as a developer as I am, but so my application might not be affected. Or there are some other reasons that people always present as like, my application is not big enough, nobody would hack it, or something like that. And this is a very narrow perspective that you can take in parts of security, because you have to take into account that your code can be broken. So, and this is a basic truth actually that is valid for every system in the world. So I keep repeating that in all of my talks, and I say every system is vulnerable to attacks. It doesn't matter how large it is, doesn't matter how small it is, doesn't matter how much time you put into it. So even large corporations have systems out there that are majorly vulnerable. So if you think that your application is not big enough, or that your code base is so small that you can take everything under control, this is not true at all. And I can prove it that it's not true. So just to prove the point is, if you think about the iPhone itself, the system, the hardware, the software, everything in it, you can think about it as a work of art. So Apple has put a lot of engineering effort into the hardware, and they are one of the largest company in the tech sector, and they have so many people working on the iPhone, on the hardware and software, and still it has vulnerabilities and bugs and stuff like that. So we as developers, as solo developer, I know that a lot, and we don't have that much of resources, we don't have that much of money to put into an application to guarantee that the whole code base is free of bugs. So you can think about your application as some kind of bullshit that's put on top of a perfectly fine-tuned machine, which itself already has vulnerabilities. Although it's so perfect, it still has vulnerabilities. So just think about that for a few seconds, that even if you do care about security, if you do care about your users' data and their money, if you have a payment application, for example, you still won't get it right, because it's very hard to eliminate or to find any of the bugs. And the reason behind it is, you can think of bugs in terms of probability, and if you believe statistics that are available, and one of these statistics is the very good book Code Complete by Steve McConnell, we think that every application, every system has 1 to 25 bugs per 1,000 lines of code. So that's true for any system, no matter how large. You can reduce that probability to 0. You can produce code that has almost 0 bugs per 1,000 lines of code, but it's very hard and very expensive to do that. So for example, if you think about the software running on a NASA space shuttle, for example. So they will put a lot of effort to make it very, very secure, but it costs a lot of money to do that. It costs millions and millions of dollars to do that. So if you think about a regular application, you will probably even have 10 times the amount of bugs per 1,000 lines of code. And these bugs can vary. It might be a functionality bug, so the system could be broken, or just memory leakage, stuff like that. So everything can be inside these 25 bugs per 1,000 lines of code, and to a degree it will be security bugs. So it's inevitable. So no matter how much time you take in order to build the application, it will always be partially faulty. And the other reason is, even if you think about your application in terms of being a very, very well-designed part, a very well-designed code basis, then you are usually using other people's code. And the example from XKCD, if you don't know the webcomic, I can. It's a very funny webcomic which everybody should know who works in IT. And they coined the issue with this picture. So all modern digital infrastructure contains functionalities from other libraries, from third-party libraries, and some of that are really, really vulnerable, and they are present in each and every system that is available on the market. So one example of it would be Log4j. If you have seen that in the news in the end of last year, which was a vulnerable system logging framework, which was developed by and maintained by one person, and it was in so many systems that one major vulnerability in that system could take down a lot of systems at once. And this is also true for mobile applications, because you have server-side code where you could have used Log4j on the mobile phone. There are even other vulnerabilities. So for example, if you think about networking, you will use some GitHub repo that provides any network functionality, and this could be faulty, or you're using something for the UI which could be faulty, or logging framework which could be faulty. So it's always risky to use other people's code, but it's also you almost can't ship software without using third-party libraries nowadays. Another reason why it's true that each and every application is broken and vulnerable is that you're programming for Satan's iPhone. And the term was coined by Ross Anderson, who had presented, it's a very old paper about computer security, and there he coined the term Satan's computer, which he used as an explanation why we should take into account that the system that our application is running on is not trustworthy. You cannot trust that the system behaves under any circumstances how you think it should behave. So you should always assume that Satan himself is running the system on which your application is sitting on top. So, and it makes totally sense if you think about it in the context of jailbroken iPhone. So this is Checkra, one software that you can use in order to jailbreak your phones. And running your application on a jailbroken iPhone is the core principle of running on Satan's computer. Because what a jailbreak actually does, part of it disables all the nice features that make an iOS system secure. So if you just think about one feature, which is code signature, code signing, in order to run an application on an iPhone, you have to sign it with a certificate which is provided by Apple. And that's why you have to deploy your apps to the App Store, and you have to have a developer license. And with the developer license comes a certificate that you can use for signing the application. And on top of that, when your app was accepted by Apple, they will sign the application on top. And they make sure that the application code cannot be altered and only apps that are approved by Apple run on the iPhone. In order to jailbreak a phone, that's one of the first mechanisms that you have to disable, because you need to run an application on the phone that will change the system behavior. And that is not possible with a standard application, let's say it that way. So if the user of your application has a jailbroken iPhone and your app runs on top of it, code signing is broken. Maybe sandboxing is also broken. This might be the case. So other apps could access the data of your application and you wouldn't even know. So that's what you have to take into account when developing application. And it depends on your application on how much you have to take that into account. But we will come to that later on in the talk. So you always have to imagine that even though the systems are secure and Apple ties everything down, there could be a case and there's a probability, because a lot of people jailbreak their phone, where you're running your application on an untrustworthy system. Another part of it is, mostly all applications communicate with the internet, and the network connection might also be not trustworthy. Just think about your users running the application in a Wi-Fi hotspot in a hotel or on a train station. So it would be very easy for an attacker to control the traffic of the application, and we will come to that later in the discussion. But generally speaking, almost anything that's surrounding your application, almost any system that you're interacting with, is untrustworthy. And that's why we talk about Satan's iPhone, running application on Satan's iPhone. And in the end, even the user is not trustworthy, because you always have to question what the user inputs into your application, because it might be an attack also. Okay, so the question is, let me just skip to that. So the question is, now we have understood that, stuff can go wrong within application. Why do I need to care while developing my application? And this is actually a picture of a real envelope that I usually have somewhere next to my desk, because it keeps reminding me how expensive it is to fix a bug in different phases of application development. So if I detect a bug while designing the application, it will be less expensive to fix it than when I've already started developing. And it will be less expensive detecting it while developing than when I've already tested. And then especially in the end, if I release the application and it's already available, people are using it, and the app gets the bug gets detected, then it will be more expensive. And that's the factor. It's not like that it will cost you $10 or 100 or 100,000, but it's the factor. It's 100,000 more times more expensive to fix a released bug than to fix a bug on paper while you're designing, because it's very easy to rewrite something on paper. So just think about it, and you will come to the conclusion that it's very important to have to be testing while you're designing, to be testing while you're developing, to be doing security tests as part of your deployment strategy, to do security tests while you're beta testing, and even after release. So it's a continuous process, actually. And the question is now, how do we test our applications? One technique in order to test your application is peer review. And that's a very important one. So if you're working in teams of developers, that's pretty easy, because one developer can always ask the other one to check his code and vice versa. And that's something you should always do. Or you could start with like peer programming or extreme programming, where you sit with two people next to each other and like code in teams. So you will be reviewing while you're actually coding. And this is a very helpful strategy. If you're a solo developer, try to find other developers that you know that have expertise in your area, and try to connect with them, maybe exchange ideas. You can review my code while I review your code. And that's what you should actually do. The question is, how does code review work? Usually you will go through your code line by line and check if you can see anything that is broken. And this is true whether you're testing functionality or checking for security bugs. But the most important part of it is not to check too many lines at once. So while you're stepping through your code, you should really never ever do like more than 400 lines per session, and a session would be like an hour or 90 minutes. So because we have statistics that show you that if you analyze more than, let's say, 400 or 500 lines in a session, that you won't detect any bugs. So the detection rate will go slowly down and down the more lines of code you're checking. And it's easy to understand that, because just think about it. You're stepping through the code line by line, which is very boring, and you lose concentration and you lose focus. And the longer you do it, the less bugs you will find. And if you have ever peer-reviewed a paper or document or something that you have written for school or at work, it's the same for text. Actually, it's the same process with text. If you're reading your own text that you have written, it's even worse. And the same is true for code. If you're reviewing your own code, you will never ever find any bugs, because you would have fixed them if you have found them. Because you have written it. And the more time you spend while checking, you will find less and less errors. So the best strategy is like to take 200 or 300 lines of code in a 1 hour session, check them very, very thoroughly, and then make a break, or even don't check any code on that day anymore. So leave the next 200 codes for the next day or for the next session later on that day. And if you do that, you will find, if you do more than 500, you will miss 70 to 90% of the bugs. Okay, so this is actually one strategy to check your code, is peer review, code review. The question is, what are you looking for in terms of security? And I'm always a friend of not reinventing the wheel. So you should use what is available. And one party that is heavily providing information in order to secure web applications and mobile applications is OWASP. And OWASP, they have, if you don't know them, you can check it on the internet, and they have very helpful resources in terms for security. And what they keep publishing is the top 10 risks for mobile. They actually started with the top 10 risks for web applications, and then later on, since 2014, they're also publishing the top 10 mobile risks for applications. And we have 2 iterations of their top 10 charts being released. One is the one from 2014, and the other one is from 2016. And you can see that the risks have changed a bit in the 2 years between the release, and that they have new risks which were introduced. So if you look at the 2016 list, you have as major risk number 1, it's improper platform usage. The second risk is insecure data storage, which means applications are storing their data, for example, in plain text, or storing security keys or encryption keys in the file system, which is insecure. Or insecure communications, which has anything to do with communicating with your server. Insecure authentication, for example, password leakage. Insufficient cryptography is the number 5 risk. Insecure authorization, if you check if your user is allowed to do something and you have faults in that check. The client code quality, which is a high risk that is most times overlooked, because people don't think that, for example, commenting code or structuring code will help them increase the security of their application. But it's really true, because if you're doing a more organized approach, then you're thinking about your code, and it's easier to maintain and fix code that has a better code quality. Code tampering, this is something which is not relevant for all applications, but is if you have an application, and we'll come to that later, that needs special attention, you could also do checks that prevent others from tampering with your application once it's running and installed. Same for reverse engineering and extraneous functionality, which means functionality that was not intended. So the list is good if you take these risks into account and check for anything that's related to these risks, you will be on the good side. The bad thing about the OWASP Mobile Top 10 is that it didn't get an update since 2016. So we are already 4 years since the last release, but I think there will be a release soon. And the risks might have changed. So it could be possible that other topics are being introduced and other topics are rated higher than they are presented right now. But you should always use that as reference. The good part about OWASP is they have released 2 very, very, very good publications about mobile security. One is the so-called Mobile Application Security Verification Standard, and the other one is the Mobile Security Testing Guides. These are available as GitHub books, so as Git books, and you can access them for free or get a printed copy if you want to have it printed. The difference between the 2 guides is the Mobile Application Security Verification Standards defines actually the requirements that apps should fulfill. So it states what security implementation should your app contain. The Mobile Security Testing Guides gives you tools and strategies on how to test and verify that you meet the requirements. So they go hand in hand. I always say the Mobile Application Security Verification, you should take that into account when you're designing and developing the application, and the testing guide is actually the workbook of hands-on testing for what you have implemented. So if you check the verification standard while developing your application, you will try to implement all the required security features, and later on you take the testing guide and check if you have if the implementation that you did fulfills the requirement. So it goes hand in hand at different stages of your personal development process. We'll deep dive into the Mobile Application Security Verification Standard. I will explain it in detail. And then we will move on to one example of testing, because the testing part is, you can really spend quite some time with testing all the different aspects of your application, and I wanted to show you one example in detail. So if we are talking about the verification guide, it splits applications into different verification levels, and therefore the requirements also in different levels. The lowest level is the level 1, which are generic security requirements that every app should implement. So without giving the context of the application, any app that is built should fulfill the level 1 requirements. Then you have level 2 requirements, which are needed if you need to defend your app in depth, which means you need to have a more resilient app, an app that is really equipped to be exposed to a very high critical environment and will still be resilient against several attacks. And the topmost is the level R, which stands for reverse engineering requirements, and this one defines requirements that help you to protect your app against reverse engineering attacks. And we will see later on what that means in detail. The good thing about this is you can combine them. So you can combine level 1 with R or level 2 with R, depends on your application. So if we look at level 1, as we can see, level 1 should be applied to all mobile apps. And it lists best practices that can be followed without investing too much into security. That's the good thing about the level 1. So if you want to implement everything that is in level 1, usually you don't need that much effort for it. So, and level 1 should be applied to any application. If it doesn't qualify for the other levels, then you should always take the requirements of level 1 as base standard, let's say it that way. If you want to have a level 1 application that's hardened, then you can combine it with the R level, and this is especially suited for apps where you need to protect the intellectual property within the application. Let's say you have some data that you want people not to extract from your application. Or one very good example is gaming industry. So if you are developing a game and you want to harden against mods and cheaters, then you could implement the requirements that are defined in level R, additionally to those required in level 1. And it will be very helpful for your application. So you have to think about your application in terms of context, because you could easily come to the conclusion, if we look at the last slide again, that, yeah, I want to be on the safe side. I'll implement all the requirements, level 1, level 2, and level R. And this would be too expensive and would consume too much of your time. Let's say, for example, the very trivial app that I presented in the introductory slide that calculates the time of death. Yeah, you wouldn't need to implement any of the R level requirements. It's easy to see that this is a level 1 app, especially because it doesn't have any network connection. So if you look at level 2 applications, this is especially suitable if you're developing apps for the healthcare industry, for example, or financial industry, because there you have like regulatory requirements which should be met. For example, PCI DSS for payment applications. So if your app contains payment, it has to be hardened in a special way. And these requirements are also met if you take into account the level 2 requirements. And if you have a full-fledged application that needs the highest, most possible security protection, you could combine level 2 and level R, and especially for finance applications, mobile that need apps that need to protect, for example, sensitive data. Think about health applications again, and especially if you want to protect against reverse engineering. And one example is mentioned here in the slide, which is apps that have in-app purchase but cannot rely on a backend. So usually you say when you have in-app purchase in your application, you should protect the content on the server side and not on the client side, because you can easily manipulate the client side. But if it's not possible because you don't have a backend, or there is no backend which can fulfill the technology, you should at least do the R level requirements in order to harden the app on the client side. So if we look into detail in the requirements categories, so the first one is actually architecture, design, and threat modeling. It consists of 12 requirements. You can read them all up in the Git book, which was linked in the slide in the beginning. But just to give you an idea of what is meant by that, this talks about security architecture. So how is the backend protected? How do they communicate? It talks about software development lifecycle. So how is your development process? When do you test? When do you build the security functions? It talks about responsible disclosure. So it suggests that you should offer people a way to inform you about bugs they found in your application. That's the first category of requirements in the application, in the framework. The second part is data storage and privacy requirements, which are 15 requirements that talk about how to securely store data, to prevent data leakage, so any information leaking outside your application, and how you should handle personally identifiable information, which are especially important if you're marketing your app in Europe. Then you have to meet the GDPR requirements, and these requirements will help you get that straight. The third requirements category is actually cryptography. It lists requirements such as not to hard code any crypto keys, to use the correct crypto primitives, to use a secure random generator. The fourth category of requirements is actually authentication and session management, where the 12 requirements list what you should do in terms of user authentication, password policy, two-factor authentication, biometrics, and stuff like that. The next part is network communication. This is one where a lot of errors happen, and we can see that later on. It lists 6 requirements which talk about TLS, how certificate pinning. I will cover that later on. The secure channels, secure network libraries, and others. The sixth category talks about platform interaction. This is 11 requirements in the area of permissions. Does your app use only permissions that you need for your application, or are you accessing privacy aspects that you shouldn't? Input validation, which means that you should validate any data that comes into your app, either through the user interface or from the network. It talks about not caching or clearing caches, so your cache policy. The seventh requirement category is actually code quality and build settings, contains 9 requirements in terms of code signing, debug code, error handling, which is very important, external library testing. And the eighth part talks about this resilience requirements, which are like jailbreak detection, obfuscation, emulator detection, and device binding. In that part, I have to point out that especially the resilience requirements are not really, you cannot really think of them as security requirements. It's more obfuscation than security, because you just make it harder for the attacker to find stuff within your application, and it's easily understandable if you think about it in terms of jailbreak detection. So jailbreak detection, the idea is that you will detect if the device is jailbroken that your app is running on, and if it's true, then you will, for example, delete your crypto keys so that nobody can access them on a jailbroken device, or delete the user data, or simply just inform the user about the risk that he's running your application. Let's say you have a banking app, developed a banking application or payment application, and you would want the user to know the risk that he's running his banking application on a jailbroken device. This is the idea of jailbreak detection, and it's easy to understand that the only thing that you can do in order to detect if the device is jailbroken is to check the device itself and see if you can do stuff that is usually not possible on non-jailbroken devices or stock devices. And for jailbreak, it's easy to bypass your check because the device is manipulated. It can behave in a way that you think it's not jailbroken, but it's still jailbroken. So the device will simply lie to your application and say, okay, you're trying to do that, but that's not possible, although it is possible. So that's not really security, but it's important in terms, for example, the examples that I mentioned earlier. For example, a banking application, you could just quit the application and stop working, discard all your critical data. So after we have talked about all the different categories, I want to step deeper into one of the categories, which is the network requirements. And the requirements themselves are split amongst the levels. So the level 1 requirements are actually only 3 of the, if we go back, we can see that the network communication has 6 requirements, and only 3 of them are applied to level 1 apps. So any app should fulfill these 3 requirements in order to be secure, no matter what the context of the application is. And if we look in detail, the first one is a requirement that if you're building an application that communicates over the network, you should only use encrypted network, for example, protected with TLS, and the secure channel is the only one that should be used, should be consistently used through the app. The second part, so in terms of an app that uses a web-based backend, web application as a backend, this would be covered with HTTPS connections. Second one says the TLS settings should be in line with current best practice, or as close as possible if the mobile operating system does not support the recommended standards. So in terms of iOS, if you're using standard HTTPS via any of the iOS frameworks, this will be fulfilled. And the reason for that is application transport security provided by Apple. And the last one is the app verifies the X509 certificate of the remote endpoint when the secure channel is established. Only certificates signed by trusted CA are accepted. And even the third one is already fulfilled if you use the standard networking libraries that iOS provides. So you can easily apply these, and this was the requirement of the level 1. if you remember what I've explained earlier, is the level 1 requirements are usually easy to implement. It doesn't even require you to write code. If you use the standard libraries for networking, these are already fulfilled on iOS. So why are we talking about it? It's because, although it is easy to fulfill, you can disable these protection mechanisms. And one part of it is you can disable iOS app transport security. And it looks like that. You have your application running on an iPhone, and you're using the standard networking libraries that the iOS frameworks provide you. It doesn't matter which of them, but no external third-party networking code. And the fact is that if you try to use an HTTPS connection, that this will work. And if you try to use HTTP plain connections, this does not work. It is blocked automatically by iOS. And you can test that. If you have an application and you have a backend that has both HTTPS and HTTP available, you can test it from your application, and you will see in the console log that iOS is preventing any HTTP connection. The problem with that is that you can disable that protection as developer. Question is, why would you do that? Here's just one example. If you're using the Ad SDK from Google, so I think the current name is Firebase, but the usual name that it is known under is Google AdWords, and you will try to integrate that in your application, the framework. It's an external framework. You'll integrate it, and it won't work because some of the connections are not over HTTPS for the ads. So if you encounter that bug, it will tell you in the developer documentation. You will just have to disable, and it doesn't even say you will be disabling ATS. It just says app transport security is a privacy feature introduced in iOS 9. It is enabled by default for new apps and enforces secure connections. So if you're having a problem with that, with the ad framework, just simply put this code into your info plist, and then it will work. And what this code does is disables app transport security. So after you've introduced this code, you will be able to do this. And now your app has opened up a vulnerability, and you're not fulfilling the requirements of the level 1 anymore. That's just one reason why people tend to disable ATS. Another reason is actually poor advice from Stack Overflow. And this is quite common because usually, even if you have if you're building your application and you're planning to use HTTPS on your production environment, oftentimes you will have a test server while you're developing, which is just HTTP enabled because you didn't buy the certificate, or nowadays you don't even need to buy one. You can just get free ones online, but still sometimes you have a local host just running which doesn't have HTTPS enabled. So this is a valid question. What settings do I need to put in my info plist to enable HTTP mode? So the developer here tried to access the HTTP resource, and the console log, here's the actual message that you'll get in your console log. It will tell you that's not possible. You need to change your info plist. It doesn't say what you need to do in detail. And the highest voted solution just says you have to set NS allows arbitrary loads key to yes in NS app transport security. And this just means disabling NS app transport security completely. And although people in the comments are pointing out that this is dangerous, you can see it here in the lower comments, let it be known, this is a workaround. Anytime you're using HTTP over HTTPS, you're opening up your users' devices to vulnerabilities. The next one, again, this is not a solution, this is a hack. While this solution is known to be vulnerable, it is the only solution I would recommend during development. It's stated out again. So although there are these comments, this is the highest voted comment. And way below, and I think this one referenced it, this is not a solution, this is a hack to add individual domain exceptions. See this answer below, and it points to another one. And this one actually tells you how you would do that for a development server. You wouldn't just simply disable application transport security for all your connections, you would do that on a exception domain, and this would be the domain name of your test system. So you would disable that just for the test system, and on the production system, you would have a different domain name. So even if you forget to remove this part of your info plist before publishing to the App Store, you would still not be vulnerable, but because only app transport security for your test system would be disabled, and the test system wouldn't be available online anyway. So that's the right way to do it. And even if you do it that way, it would be very important to remove that entry once you publish the application, but still not a big problem if you don't do it. So if you do it like that with an exception domain, you would still fulfill the requirements of level 1. So another question is, how can you check if your servers if your backend is actually compatible with ATS? So ATS does not just prevent HTTP requests. It, for example, also prevents TLS 1.0, 1.1 connections, so older implementations of HTTPS. And you can use this command line tool on your Mac in order to check if your backend is actually would pass application transport security. So it's NSCur, which is used for a lot of reasons on the command line. You would add the flag --ATS-diagnostics --verbose to get a full list of reasons, and then your domain name. And if you hit enter, it will check your backend with all different ATS configurations. And if the connection is possible, then it would say pass. And if it's not possible, like it is here the case, it would say fail. So an HTTP, if you put here an HTTP target without S, then it would fail all connections, because HTTP is completely not allowed for your domain, from ATS side. So that's how you would test if your backend is vulnerable or is compatible with ATS, actually. So if we dig deeper now into the network requirements, into the level 2, now we have additional requirements. The remaining 3, if you remember, there are 6 in total. The first 3 were level 1 requirements. The second 3 were level 2 requirements. And here it is: the app either uses its own certificate store or pins the endpoint certificate. So if you're building level 2 application, here the examples are healthcare app, financial app, then you would need to implement certificate pinning. I'll explain what it is in detail. The second part is the app doesn't rely on a single insecure communication channel, so email or SMS, for critical operations such as enrollment and account recovery. So the second requirement would disallow you to use, for example, SMS verification for login. The third requirement is the app only depends on up-to-date connectivity and security libraries. So anything that you use, even if it's a third-party requirements, and I know there are quite a lot of networking requirement, third-party libraries for networking for iOS, you would have to ensure that you're using up-to-date versions of that library. So how do we test for this part? So in order to understand how we can test for this, I have to take like a quick explanation of certificate pinning. So if you think about how the internet works in general, the trust model of the internet, it's usually you have a computer, a phone, and a browser. So if you have a browser, user sitting at a browser, so it's not an iOS app, but the browser. Let's say Safari on your iPhone or on your MacBook. You can call any website that you want, and the browser manufacturer cannot predict which websites the user will load, and it's not possible to predict that. So any site should be possible. It could be an HTTP site, which is obviously allowed in a browser, could be an HTTPS site. So if he navigates to an HTTPS website, let's say, for example, Google or Dropbox, before accessing the content of the page, he will be presented the certificate chain of that website, which means in this case, Google bought a certificate for their site from GlobalSign. GlobalSign has a certificate hierarchy, so the root certificate has signed the second level has signed the third level The third level has signed the google.com certificate. So, and the highest level, the level 1 certificate, the root certificate, is already pre-installed in your operating system, macOS or Windows or whatever your operating system is. So if you navigate to the page, it will get presented all these certificates. It will check the google.com certificate and see that it's signed by this one. We'll check this one, we'll see that it's signed by this one. We'll check this one, see that it's signed by this one, and this one is trusted by the operating system. So the whole chain is accepted, and you can be sure that nobody is eavesdropping on your communication channel or manipulating anything. If you navigate to a different site, then it will be a different chain. For example, Dropbox is signed by DigiCert. So, and the DigiCert certificate, the root certificate, is also pre-installed in iOS and Windows and macOS. So the whole trust model is we are trusting anything that these pre-installed root certificates have signed, and they are making sure that that no fraud happens while signing the certificates. So if you have an attacker sitting between your computer as a user and the internet, so let's say you're connecting to Wi-Fi hotspot at the train station, and you think you're connecting to the official public Wi-Fi access point, but it's an attacker-controlled access point. So he could just simply, if you call google.com, he could call it in your place. So this connection would still be HTTPS with the whole chain, but before serving the site to you, he would exchange the certificates. He would use his attacker certificate and sign a new google.com certificate and present it to you. This attack wouldn't work because the root certificate is not trusted by your operating system. So the check would be simply, oh, here's a certificate by google.com. And the next one in the chain, I don't know that certificate. So communication is blocked. It's not possible. So what the attacker would have to do in order to get you to trust that communication session is he would have to inject a root certificate in your system. That's not impossible, but it's also not easy. So it's a possible attack, but not impossible. So the problem here is if we can install root CAs or get the user to install a root CA on the system, then we can manipulate this connection. So we can read the data. That's the lowest form of manipulation, but we could also inject other values and manipulate the whole system. So this would be the end goal for an attacker on the communication session. How does it look for an application? So the trust model for an application is different. If we look back at the browser trust model, we were confronted with any possible site. It could be anything. It doesn't even have to have a domain name. It could be a machine running on IP. So for an app, it's different. It usually connects to well-known servers, your app backend. So it doesn't have to trust all the different global sign, DigiCert certificates because you already know what certificates are on your backend. So if you want to make sure that the connection stays secure, you would just check, is it the certificate that I've installed on my server? So the yellow server would have this certificate, and you would pre-install that certificate into your application. And the same for the purple server. And now if you start the HTTPS connection, you will get presented with the certificate, and you would just, for example, compare them. Are they different bit by bit? It's the same certificate, okay. Because the attacker cannot sign the connection with a certificate because you're the owner, you own the private key. And that is called certificate pinning. So you don't trust all the certificates that are pre-installed in your system. Here in this case, in iOS, you would just trust the two certificates that are connected to your server. This has the advantage that you can be very sure that the connection is secure. The disadvantage is if you need to change your certificates on the server side, you would have to do an update to your application. But you can prevent that also if you look at the chain. So what way of doing it would, if you have an app that connects to google.com, you would just trust the global sign root CA. That's just one root certificate instead of 200 pre-installed in your system. And then you can be relatively sure that you are connecting to the right server. So unless someone managed to hack global sign CA infrastructure. So this trust model is very different, and that's why level 2 apps should pin certificates. So if you look at it from the testing perspective, if you have an application and you want to find out if it uses certificate pinning or if it correctly verifies your applications, you could use a man-in-the-middle proxy, for example, Burp Suite. I will show you in screenshots briefly how you can do that. And you would place that between your app and the internet. If plain HTTP is possible, so that's a test. So if you can read the communication between your app and the backend, then it's plain HTTP, and this is completely insecure, and you already get a hint that you have ATS disabled somehow, because this shouldn't work on iOS. If it's HTTPS, but you can read the content of your connection, then your certificate validation must be broken, because that shouldn't be possible unless you have a root CA installed, and this one is the root CA from the man-in-the-middle proxy. If this is not possible, then the certificate validation is okay. If you install a root certificate and you still cannot read the content of the connection, then it looks like certificate pinning is active. Because although you have pre-installed a trusted certificate from the attacker's perspective, you still cannot read the content, and this means somehow the app is checking that the certificate is valid or not, and this points in the direction of certificate pinning. So this setup is really easy to create, and you can test all your applications, even third-party applications, in determining whether it is fulfilling the level 1 or level 2 requirements. So how does that look in practice? This is the user interface of the Burp proxy. If you start it, it will start in that screen, and you have the proxy settings, which is the third setting in the top. You would navigate to that, and you will have an options setting there. And in the proxy listeners part, you will see that it has already pre-configured a proxy running on your local host. This is helpful if you want to check the connections running on the same machine, so on your laptop, let's say on your MacBook. But what you want to do in that scenario is you want to check the connections from your iPhone, which need to be on the same network. So if you're in the same Wi-Fi, you would just click on the Add button and add another binding, and you have to specify a port on which this proxy is listening. In that case, it's random. You can choose any one that is not already in use, and you would use the local network address of the Wi-Fi IP address of your machine. So it would listen on that IP with that port on incoming connections. Then you would change to your iPhone, to the Wi-Fi settings, scroll all the way down to the bottom, and you can configure a proxy. You will set it to manual, and then you will just input the server IP address and the port in the settings. This will lead to the application using the HTTP proxy listening on that port. So any connection from the device which goes over HTTP or HTTPS will be forwarded to that proxy. You can see that easily if you then use your browser, navigate, for example, to http example.com. You will see the request here in the HTTP history, and you will see the content that the web server provides. So as you can see, you are the man-in-the-middle attacker, and you can see all the connections over HTTP that the phone sends out. If you try to open HTTPS website, HTTPS protected website, your browser will simply just show you this error. You will know that error from sites that have expired certificates, for example. And this is how it looks in Edge on iOS, and this is how it looks in Safari on iOS. So this won't be possible, and you wouldn't see the requests coming in here in the HTTP history. So in order to get that running for testing, we have to manipulate the device. And that's the second part. We have to install the root CA that Burp uses. In order to do that, you can just call via HTTP Burp, and then it will present a page, and here in the top corner, it will provide the CA certificate. If you click on it, your phone will download the configuration file for that, And this is already a hint from iOS that you're doing something which is critical. This website is trying to download the configuration profile. Do you want to allow this? You can say allow, and then it will say profile downloaded, review the profile and settings. So it won't be active yet. So even if you get a user as an attacker, if you trick the user to try to install a certificate, this is just the first step. The second step would be you would have to navigate to the settings, and then it will appear in the top of your settings panel, profile downloaded. Then the profile will be presented if you click on it, and you have to click install. Then you have to enter your passcode if your device has a passcode. So that's one reason that you should take into account that you should use passcodes on your device, or your configuration can be changed. Then it will give you an additional warning. You see how critical iOS thinks the action is. It will tell you are installing this. The authenticity of the man-in-the-middle proxy cannot be verified, which is true. Then you still have to click on install and a second time on install, and then it will be installed. But even then, you're still not finished because the profile is installed, but the operating system does not trust the root CA automatically. And this is an additional layer of defense of iOS. So you'd have to navigate back to the settings, then to about section of the settings, scroll all the way down to certificate trust settings. And there you will see the installed certificate in the middle, and it will be turned off. If you switch, if you click on the switch, it will tell you root certificate warning. Enabling this certificate for websites will allow third parties to view any private data sent to websites. If you then click on continue, then you have successfully installed a new root CA in your iOS device. Oops, that was too fast. And if you navigate to an HTTPS protected website, this will work now. And the same would be for your apps. And you can see the request here. You can see that's an HTTPS request. And although it should be encrypted and integrity protected, you can read the content. And if you activate the intercept mode, which is on the top of the HTTP, left to the HTTP history button, then you could even intercept the request, change the content before it's sent to the device, and test the behavior. And this actually concludes the session. So now you know how to install a root CA on your system and get a proxy in between your app and the app backend. This is a mechanism that you can use in order to verify if you have fulfilled all the level 1 and level 2 requirements of the networking category. And it's the same behavior that an attacker would have to use in order to get between your app and the backend. If you want to know more about the other requirements, if we step back to the slide where we list what we now did is we used the requirements in order to understand what we need to implement, and then we used the strategy that is pointed out for testing the requirement, which is the scenario with the proxy. So you can read that everything up in the Git books presented in the links here, and that this would be all from my side. Unless you have any questions, you can ask me now.
Thank you. Thank you very much, Rashid. It was really helpful. Do we have any questions? If so, please leave them in the comment section for this event. I personally didn't know about the verification levels, by the way. Okay, so we have a question.
Yeah, the first question is, how do you approach certificate? Yeah, let's encrypt. Yeah, that's a good question. They have short cert validity for the leaf certificate. So if you go back to my slides, that was the part that I was earlier talking about. for pinning, there are different strategies. You can pin the leaf certificate, so the lowest level, the one that's tied to your domain, or you could pin any certificate higher in the range. So for Let's Encrypt, if it would be sufficient to pin against the root certificate of Let's Encrypt, and that doesn't change that often. So the ones that change are lower in the chain. But you're right. If you have to rely on the service, there's only two ways: pinning against the higher hierarchy certificate, or updating your app in time before you change the leaf certificate, and that's not possible.
Thank you. Yeah. Also, I didn't know about the Git books. This is definitely a must read.
Yeah,
I
definitely. These ones.
So we will have the slides and also the video recording for this event published in the um, Facebook group, and also we'll have the video on YouTube, and you will receive also links for in the mail after this. Also, we have another question.
Any frameworks that could help us implementing the security, for example? Yeah, there are. So there are several third-party providers that will present you with frameworks that can help with that. And if you want to find a suitable one, because it depends on what kind of application you're using, just search for app hardening frameworks. Usually called hardening frameworks or container frameworks. And these are used in order to encapsulate the critical functionality of your app within an already implemented solution that fulfills the requirement. So there are special ones for banking applications, for games and stuff like that. But the overall search term is hardening frameworks.
Thank you. I also remember in my previous company, we also hired a third-party company which was testing our app. It was a bank app, and they were reverse engineering and basically tell us where we have vulnerability, and also they gave us some tips on how to improve some stuff.
Yeah. I think that's always a possibility. You can hire also pen testers for your backend systems, but it's a question of resources again. How much can you spend on that, and what's the return on invest? So you should take into account in which level your app is sitting. So for level 1 app, that doesn't make much sense. But if you're targeting like finance, I think finance and health, and these are the most relevant areas where you should definitely consider hiring someone to check your code.
Right.
And your backend.
Okay, thank you very much. If we don't have any more questions, and I don't see any. Oh, we have let me display. So how is the concept of DevSecOps applicable in the world of mobile application development?
Oh, that's a good question, which would be I think a good topic for another SwiftSofia session, because it's a very broad topic. But in general, have your security people and dev people talk to each other and try to introduce your security implementation within the development lifecycle and your deployment lifecycle. So there's no easy answer to that. Let's put it that way.
Right. So
very broad topic.
So you're welcome to a follow-up SwiftSofia.
Yeah, we can do that. No problem.
That would be nice. Thank you very much. Thank you for your time and this topic. This topic is really interesting and also important.
Yeah, and if you have any additional questions, you can find me in LinkedIn, Twitter, anything. Feel free to contact me, or you can ask Veronica for the contact details.
Yeah, we will publish together with the video and also the slides. We'll also make sure to include your contact. Thank you Thank you very much. Um,
It was a pleasure.
Thank you. As I said in the beginning, this community is built by developers for developers. So if you wish to talk about Swift or iOS topics in a future SwiftSofia event, contact us, and we will have another SwiftSofia event soon. Thank you very much for your participation and have a good night. Bye.